Howdy, folks. Hope you're doing well today. I have a sick little boy, so I am not able to join you. Let me make sure everything's coming along right. It looks like we got audio and video. Um, hey, we started Friday talking about the definite integral, and I think you picked it up pretty quickly. Today I'm going to show you how to deal with absolute value. It's actually fairly straightforward. And yeah, I said that again, didn't I? How about that? But hopefully you can pick it up. If you'll remember last time, we talked about this graph, and I think we figured out the integral from 0 to 5 of 3 minus x was, I believe it was 5 over 2. Hopefully that's right. Okay, this is going to be my issue for the day. 2. And it was 5 over 2 because of signed area. So if you remember the graph, this is a crude sketch, but this was positive, and we actually subtracted this area here out from the answer. All right. So I actually have a graph here. So positive area, negative area. Okay. So the question becomes, what if we have something of this nature? Okay. Basically, what you're saying there is no negative signed area. Okay, so that's number one. Number two is we've just split it into two integrals. Okay, so let me show you a graph here. That's what it looks like. So you can see before, here's the original. It pops down in the negatives right here. But before, on absolute value, it's not going to allow that. It's actually going to come back up here and stay in the positive. So what we have is two positive areas, and the area is actually going to be larger. Okay. Notice that at x equals 3 is where it bounces back up. So that's the X intercept. Okay, that's key. That's what you want to find. Okay, so we need to calculate. Oh, that is ugly. Okay. Calculate X intercept. All right. Algebraically, so you saw it graphically, right? Algebraically, where does that equal 0? Well, if x is 3, it's 0. So that's, you know, that's your where it changes direction. Okay, so when you set these up, going from 0 to 3, and this is the positive case. All right, so pay attention. This is in here. It was positive, and it stayed positive, so we're not going to change it. Okay, the other one is negative, and it changes to positive, so we have to multiply it by a negative sign. Okay, and we're going to add it to the negative of 3 minus x dx. Okay, so we've had to split it into two different integrals. so that we can deal with that absolute value and we get a positive answer. All right. I am going to put a new page up, but I'm going to rewrite that without that negative in front. Okay, there are two ways to do it. I can either distribute, okay, that's perfectly reasonable, or I can put it outside and make that a subtraction. Okay, your pick. Of course, I can't hear you, so it doesn't matter. All right. I will do the negative. Out front. Okay, and now it's a simple matter of calculating two integrals and adding them together, or subtracting in this case. Okay, so we have 3x minus x squared over 2 evaluated from 0 to 3. That is 9 minus 9 over 2 minus, so that was plugging 3, and now I'm going to plug 0 in, which is 0. Okay, so that gives us 9 over 2. And then this one, it's the same. But we're evaluating now from 3 to 5. Okay. So notice that I'm keeping the subtraction sign here all the way through, being nice and organized. So I'm going to plug 5 in. I get 15 minus 25 over 2 minus, and then I'm going to plug the 3 in, 9 minus 9 over 2 again. All right. Okay, so that's 30 over 2, so we get 5 over 2. And this one is 9 over 2. Okay, that's negative 4. So 9 plus negative 4, the answer is going to be 13 over 2. And hopefully I got that right. Okay, notice it's much bigger than the previous answer of 5 over 2. Okay, the previous answer, 5 over 2. Okay, notice the area here. And here's what's really neat. You got this area, which is 9 over 2. And this area is 5 over 2. Okay, if we subtract them, we get, sorry, wrong. Okay, that's 9 over 2. This one is 4 over 2. Now, if you subtract them, you get 5 over 2. If you add them up, you get 13 over 2. Okay, so there is a geometric way to do this. Just remember, if you're doing triangles, you have to subtract or add depending on absolute value or no absolute value. Okay? All right, I know I'm going fast, but I don't have any feedback from you, so we're just going to keep on rolling. Hopefully you're doing okay. Let's look at this. Whoop, want an A there. I want x squared minus 4. Okay, and we want to calculate integral from 0 to 4 of x squared minus 4 dx. And we want the absolute value on there too. So check out the graph. Okay, here is x squared minus 4. No absolute values, you can see that. It just comes down. The zeros are at negative 2 and 2, and it goes back up. Okay, what does the absolute value do? all these negatives come above, and it looks like this. Okay, so you can see the zeros where it went below on the other graph, it actually comes back into the positives. All right, and we're going to do the area from 0 to 4 under the curve. Notice our X intercept, our 0 is 2, so that's where we're going to split our integrals. Okay, so we will have and again, notice x squared minus 4 equals 0. There's your algebraic method to find the zeros. Okay, so plus 4. What's that? Refresher. So x is positive or negative 2. Obviously, we're going to work with the positive version. So integral from 0 to 2, x squared. And this is where we have to pay attention. From 0 to 2 is where it was negative. Okay, it was in here negatives. So we have to put the negative in front of that. Plus 2 to 4. And that was the regular. Oh boy. Okay, running out of room here. Big fingers do not write well. Okay. I will run through this problem real quick with you, just to make sure you're looking at the integral properly. Okay, so the negative there, and then the integral is x cubed over 3. Boy, oh boy. Ooh, ugly. X cubed over 3 minus 4x evaluated from 0 to 2 minus x cubed minus or over 3 minus 4x from 2 to 4. Again, plug the 2 in, you get 8 over 3. Oh, don't forget. Oop, there we go. So this is 8 over 3 minus 8. And then, of course, if you plug 0 in, and then if you come over here, do not forget that negative there has to transfer to this whole term over here. Okay, don't forget that. Plug 4 in, you get 4 cubed is 64 minus 16 minus, and then the 2's if you plug them in, 8 thirds. Oh, why are you changing what I'm writing? Minus 8. Okay. Big, long, nasty mess. Well, here's what's really nice. Negative 8 thirds minus negative 8 thirds. Bam. Okay, 8. Minus, minus, minus. I think those are actually going to cancel out. Yeah, we'll just write it out because I don't want to make a mess here. Okay, so we get 8. And then we get minus 64 over 3 plus 16 and minus 8. Yeah, so they do cancel out. And what you end up with is that right there. All right. Hopefully you're following along nicely. I'll give you about 5 seconds. Almost done here. I want to show you a particle motion problem, distance versus displacement. Okay, so I think I mentioned this earlier. If you have a velocity function, this will give you displacement. Okay, that is because and that means that it'll give you, so let's say you're traveling on the x-axis and you actually turn and come back. Okay, this integral is going to give you this distance here, this displacement. Okay, that's just how far you are from your original. Okay, the absolute value if you do that same track will give you, because this is a negative velocity here, it actually changes it to a positive. Okay, and the graph of the absolute value, basically it does this, okay, and changes both of them to positive, and it gives you total distance traveled. Okay, so it changes this to a positive, it gives you the total distance you've traveled. Okay, so that's the difference between displacement and distance. For displacement, you have how far are you from your original, and distance traveled is total distance. Okay, this one here would be like going from Parachute to Denver to Glenwood. You've only displaced yourself by about 40 miles from your original, but you've traveled, that would be this one. Okay, your distance traveled is probably more like 320 miles. Okay, so let's take a look at a problem. Okay, particle moves along a line, so its position at any time t greater than or equal to 0 is given by the function s of t equals t squared minus 3t plus 2, where s is measured in meters and t is measured in seconds. And okay, this is a poor problem. Let's find another one. Because that one actually doesn't involve an integral. Okay, slow internet. There's another position. Nope. Lynn McMullen. He is a legend. Let's see if that'll download fast enough. He actually did my Cal BC training this summer, so he's pretty good. Okay. Oh, this looks familiar. Well, if you want a good overall overview of particle motion, look this up. The ubiquitous particle motion problem. Okay, it's got a whole bunch of information on it. And it's got some questions. Let's see. Yeah, not seeing anything here. I think you're actually working on that one. Okay. Let's see. All right, so if we look at B here, Karen rides her bicycle along a straight road from home to school, starting at time 0 and arriving at school at time t equals 12 minutes. And you can see that in the graph. During the time interval 0 to 12, her velocity in miles per minute is modeled by the piecewise linear function whose graph is shown above. Okay, so if we're talking A, find the acceleration of Karen's bicycle at t equals 7.5 minutes. Okay, this is a velocity function, do not forget that. So the slope, the instantaneous slope, or the tangent line at 7.5 is her acceleration. All right, and if you can look at your graph here, 7.5 is right there. Go away. So if we find the slope of that line, it's linear, real easy. You have the acceleration of 7.5 minutes. And remember to indicate units of measure. All right, miles per minute squared. All right, part B. Using correct units, explain the meaning of the integral from 0 to 12, absolute value of v of t dt in terms of Karen's trip, and find the value. Okay, so it's a little different than just an algebra problem, but if you go back to our notes, the absolute value of the velocity function is the distance traveled. Okay, so you are going to say something such as the integral from 0 to 12 of absolute value v of t dt is the distance Karen n traveled from t equals 0 to t equals 12 minutes. Okay, be very clear, very concise. You have the function, okay, you have the meaning, you have Karen traveled, okay, the distance Karen traveled, and then you have the time period. Do not forget the time period, do not forget the function, do not forget the meaning. Okay, all three of those need to be in there. And then find the value. So this is where we don't have a function, and we have to think, what does an integral mean? Okay, so what does an integral mean? Oh, it means area under a curve. Okay, and because we're working with absolute value, we're not going to have, see this area here, it's not going to be negative. Okay, we're going to have to consider it positive. So basically what you're doing is finding the area of every one of these shapes. That one is going to be positive. You just find the area between the curve and the x-axis, add it all up, you got yourself an answer. Okay, let me see if they have the key here. Yep. All right, so you can see here, the calculus folks broke it up just like I showed you. Okay, from 0 to 2 is positive, 2 to 4 is negative. So they put the negative out there to counteract it. And then 4 to 12 is positive again. You calculate those areas geometrically using triangles and rectangles, and you get a total of 1.8 miles. Okay. hopefully that does it for you. I'm going to let you go work on your homework the rest of the hour, and please actually work on it. Okay, I know you're in the habit of not, so please work on it. Bring me any questions tomorrow. I should be there. And don't forget your free response question. We were supposed to score it today. We'll just look at it tomorrow along with your homework. Okay? Have a nice rest of your day.